Welcome to RJ classes and today's topic that is the current electricity. So today we will start in last video. In previous video we had finished static electricity, that was the that developed due to the deposition accumulation of the charge on the surface of the object. But now we are going to discuss about the movement of charge. So in static electricity there was the accumulation of charge on the surface, positive, negative, that doesn't matter, but it was the accumulation of charge on the surface of the object. But now we will discuss about the movement of charge inside the object. So there are the two kinds of charge. Inside any of the object there are the two kinds of charge. One is the fixed positive charge, and again other is the negative charge, that is the electrons. So simply we can say there is the movement of electron. Whenever the electrons move from the one terminal to the other terminal in a conductor, so that is said to be the that movement of charge is considered to be the flow of electric current. So if we need to give the definition, that means we understand that it is the charge that is the moving, and that movement of charge has been regarded as the electric current. So electric current definition, what will be the definition? Flow of charge. What I am talking about, the flow of charge, it is not about the positive and negative charge. Simply we are going to talk about the charge. So flow of charge per unit time, that means in unit time, in a specific time. So the flow of charge per unit time through a conductor is said to be electric current. So simply electric current, electricity can be defined as the flow of charge per unit time through a conductor. I'm going to write the definition for you. So the flow of charge, electric current can be defined as electric current is defined as the flow of charge, as the flow of charge per unit time through a conductor. So that means if through a conductor charge is flowing, that is said to be the electric current. So mathematically it is to be represented as I equals to Q by T. So here I stands for electric current, Q stands for charge, and T stands for time. So mathematically it can be represented as I equals to Q by T. But again we are saying that it is the flow of electron, it is the flow of charge. That means what? The positive charge is not flowing, positive charge is not moving inside the conductor, only the negative charge is moving, means on getting a particular amount of potential difference. So that means we are discussing about the movement of charge. What kind of charge? Negative charge, and negative charge is associated with the electrons. So that means we are discussing, the whole topic is about the movement of electron. So if the electric current is to be represented, electric current is to be defined in term of electron, so it can be as it is. So Q, that means total charge. So one electron is represented as this one, and if suppose we have the 100 electrons, so it can be represented as 100E, and if we have the infinite number of electrons that we doesn't know, so in that case it will be represented as an E. So it can be the total number of charge in a conductor can be defined as an E by time. For time we can write it second, or we can write it time obviously, T. So electric current in term of electron can be defined as, can be represented as in this manner. So if there is a question to define electric current in term of the flow of electron, not in term of the flow of the charge, but in term of the flow of the electron, so we can represent it like this one. So if we need to give the definition in term of the flow of electron, we can write it as, see, the total number of electron, we can define it as the total number of electron flowing through a conductor per unit time is said to be the electric current. So the electric current, for we can have the two definitions. One is that is in term of the charge, and other in term of the flow of electron, the total number of electrons. And mathematically we have the two representation, this one and this one, obviously. Now we understood the definition of the electric current. Now after the definitions we need to write the unit. Every time we do the same thing, unit. Okay, so if I represent the electric current, so that means I equals to, so I equals to what will be it? I equals to Q by T. Q, that means charge, and charge for it stands for Coulomb, C. That means Coulomb is the unit of charge. Unit of charge, that is the Coulomb. So after the name of the scientist, Coulomb. So C by, है ना? I'm writing in full, Coulomb. Coulomb, and for time we have the second. So it is the C by Coulomb per second. So that is the unit of electric current. So in most of my video you have seen that whenever any of the unit are represented using two or more terms, for this one we use a single term. So Coulomb per second, for this one a single term will be the ampere. What will be? Ampere. So electric current, so unit of electric current will be the ampere. Now the another questions we have. Another questions we have is define ampere. Now we have, you will have the different questions. Define ampere. So ampere, so here we have the definition of ampere. So what is the ampere? If 1 coulomb of charge, what I am talking about, if 1 coulomb of charge flows through a conductor in 1 second or per second, then the electric current flowing through the conductor is said to be the 1 ampere. Again I am repeating it. You will get all the definitions, all the terms, each and everything from your definitions, from your mathematical representation, if it is represented properly. So suppose if you remember only this one, I equals to Q by T, you will able to give each and every answer related to the electric current. The basic answers you will able to give the I equals to Q by T. So from this one only we got the definition of the electric current. So I equals to Q by T, from this one it can be represented in term of the electrons. I equals to Q by T. So from here we got the definition of the unit of the electric current, and from here we got the ampere, and from here only we can define ampere. So ampere equals to coulomb per second. So if 1 coulomb of charge, remember, if 1 coulomb of charge flows through a conductor per second, the amount of current flowing through it is said to be 1 ampere. So that is the definition of ampere. I am writing it. If 1 coulomb of charge, flowing through a conductor, per second, amount of current flowing through it, is said to be 1 ampere. 1 ampere. So that is the definition of ampere. Now after ampere we have the another terms that is in your book, that is the potential and the potential difference. So I am going to describe the two terms. We have the two terms, one is the potential and another is the potential difference. That two terms is very important, because without applying any potential the current will not flow through a conductor. So before going to discuss about the potential, so direction of the flow of the electric current. So simply, so if we have a conductor, suppose we have a conductor, and in conductor electron is flowing in this direction. We have the positive and negative charge, and electron is flowing in this directions. So the electric current will always flow in the direction opposite to the flow of the electrons. So if the electron is flowing in this direction, so electric current will flow in this directions. So we can say the direction of the electric current is always in the opposite to the flow of the electrons. So this is the electric current, directions understood, each and everything. Now the next word is the potential. So potential. So what is potential? So potential is whenever suppose we have a unit positive charge, that means have a negligible value, have a little values. So if we have a unit positive charge and where it is that I don't know, that means it at infinity, and from infinity if we bring that unit positive charge, suppose we have a conductor, I am taking, you will understand it properly. We have a conductor having obviously positive, negative, whatever, that doesn't matter. So we have a conductor, we have a unit positive charge, and where is that unit positive charge? Is at infinity. That means particular position is not known yet. So if from that infinity, if that unit positive charge is brought to a particular point of a conductor, the amount of energy spent or the amount of work done in doing so is said to be the potential of the conductor. What I told? The amount of work done or energy spent. Remember properly. So the amount of work done or the energy spent in bringing unit positive charge from the infinity to a particular point of a conductor is said to be the potential of that conductor. So I am writing the definition for you. Amount of work done. Amount of work done in bringing a unit positive charge from infinity to a particular point, of a conductor is called potential. And what is the unit for the potential? That is the unit is volt. We can get the derivation also for the potential and the volt, but that will be too descriptive, that is not in your syllabus. So simply means know the word potential and the unit of the potential, volt. Okay, next word is the potential difference. So what is the potential difference? Suppose again we have a conductor. So this one is conductor, we have a conductor, and we are bringing a charge from this point of the conductor to this point of the conductor. So from the one point of the conductor, the amount of work done, again we will use the same language, we will use the same word, because only difference that it is the difference between the 2 points. So amount of work done or energy spent in bringing a unit positive charge from one point of a conductor to the other point is said to be its potential difference. Again I am repeating. So what is the potential? Potential, that means to bring the charge from infinity to a particular point of a conductor. And what is potential difference? That means to bring the charge from one point of the conductor to the other point of the same conductor, and in doing so the work done or the energy spent is said to be the potential difference. So potential difference, that means to bring the charge from one point to another point, and potential means to bring the charge from the infinity to a particular point of a conductor. So hope you understood these two, one potential and the potential difference. And for the potential difference, it is the same thing, but only difference is to bring the charge from one point to another point. So it has also the same unit, the unit of the potential difference, that is also volt. So in this video we understood electric current means unit of electric current, ampere, the direction of the flow of electric current, potential difference. In next video we will do some more topics, we will cover some more topic.